Assuming under root 5 is irrational, prove that 2 plus 3 under root 5 is irrational. So first we will see assume 2 plus 3 under root 5 is rational. Hence we can write 2 plus 3 under root 5 equal to P over Q, where Q not equal to 0. So if 2 plus 3 under root 5 equal to P over Q, we have 3 under root 5 equal to P over Q minus 2. 3 under root 5, take LCM is Q, so P minus 2Q. So under root 5 equal to P minus 2Q over 3Q. Now the left hand side is under root 5 is irrational. They've given it here. This is your left hand side, and the right hand side P minus 2Q over 3Q. This is rational because all the numbers P, 2, Q, 3 all are rational. So this expression will also be rational. Thus we see rational, but we know rational number cannot be equal to irrational. Therefore our assumption is wrong. In our assumption is wrong, we can say that 2 plus 3 root 5 is irrational. It cannot be rational. It has to be irrational. Prove that 2 under root 3 over 5 is irrational. Now this is a 5 marker. If this is a 5 marker, first we have to prove that under root 3 is irrational. So we assume under root 3 is rational. If under root 3 is rational, hence under root 3 equal to P over Q, where Q not equal to 0 and P, Q co-prime numbers. When we cross multiply, we get under root 3 Q equal to P. So on squaring, Q equal to P, we square on both the sides. So here we get 3Q square equal to P square. So in the next we write 3 is a factor of P square. So 3 is factor of P. This is by theorem. If 3 is a factor of P, we can write P as 3m. So we'll take up equation 1. In equation 1, we have P square equal to 3Q square. Now P we know is 3m, so this will be square 3m equal to 3Q square. So 9m square equal to 3Q square. Taking 3 common out, we get 3m square equal to Q square. Hope you have understood how we got this part. For P, I have put 3m. So in this we can now say that 3 is factor of q square. So 3 is factor of q by theorem. So now we see that 3 is a factor of p and 3 is also a factor of q. 3 is factor of p and q. Therefore, p, q are not co-prime. Because if they were co-prime, they must have no common factor. Here they have 3 as a common factor, so they are not co-prime. This contradicts our assumption. In fact, contradicts the statement that P, Q are co-prime. So we can say, therefore, assumption is wrong. If assumption is wrong, we can say root 3 is irrational. It's a 5 marker. So this was one part of the sum. Now for the next part of the sum. First part we already have shown that under root 3 is irrational. This is one part. Now for the second part of the sum you'll say let 2 root 3 by 5 be rational. Therefore 2 root 3 by 5 equal to P over Q, where Q not equal to 0. Here, since we've written P over Q already there, maybe we can write A over B now. B not equal to 0. So we have root 3 equal to 5A over 2B. This is the left hand side. Left hand side, root 3 is irrational, already proved. And the right hand side, 5A over 2B is rational. But rational number is not equal to irrational. Therefore, our assumption is wrong. So we can say 2 root 3 by 5 is irrational. Express 0.3178 in the form A over B. This is last year's portion. So we will say let x be equal to 0.3178 bar. So this is equation 1. In the next step, now we'll take up equation 1 and multiply it by 1, 2, 3, 4 zeros. So multiply 1, 2, 3, 4 zeros. So we take x equal to 0.137, not 13317, 3178 and multiply it by 10,000. So multiplying, now you get for x equal to 3178.3178 bar. This is equation 2. In the next step, now we subtract equation 1 from equation 2. So equation 2 was x equal to 3178.3178 bar, and here you have 1x equal to 0.3178. So on subtraction you get 9999x 3178. So x is 3178 over 9999, and if you can reduce it further, so thus have you seen that the number 3.78, it is non-terminating but repeating, and it can be written in the form p over q. Look here, we have written it in the form of p over q. Therefore we will say it is a rational number. So non-terminating, repeating are rational numbers. Write whether the following is rational or irrational. So we take 2 under root 45 plus 3 under root 20 over 2 under root 5. So first we'll take under root 45 and we will break it up. 45 is 335, which means 3 under root 5. Then next we are going to take 3 under root 20, break that up, simplify it. So it is 2, 2, 5, 3 into 2 under root 5, so 6 under root 5. Let's put these values. For 2 under root 5, this will be 2 under root 45 is 3 under root 5, and under root 20 is this under 2 under root 5 over 2 under root 5. So this is 6 under root 5 plus 6 under root 5 over 2 under root 5. 6 under root 5 plus 6 under root 5 is 12 under root 5 over 2 under root 5. Now here under root 5 cancels out. So it is 12 over 2, and this is 6. And we know 6 is a rational number. So we can say for the answer 2 under root 45 plus 3 under root 20 over 2 under root 5 is rational. Find the smallest number which when increased by 20 is exactly divisible by 90 and 144. So the number has to be divisible by 90, and also the number has to be divisible by 144. So you'll definitely agree that x has to be the multiple, but when it has to be increased by 20. So we'll say let the required number be x. Now to find x, we need to find the LCM. Because the number has to be divisible by 90 and 144. So let's go ahead and find the LCM. Prime factorization of 90 is 3 square into 2 into 5, and 144 prime factorization 2 raised to 4, 3 raised to 2. So when we do the LCM, we write all the factors, that is 2, 3 and 5, and the highest power 4, 2 and 1, and the LCM works out to be 720. But 720 is absolutely divisible. Look at this. We have 720. If we divide by 90, you will write 8, remainder 0. 720, you divide by 144, 5, remainder 0. But we want, if increased by 20, The number should be increased by 20 to be divisible. Therefore, the required number, the number equal to 720 minus 20, which is 700. Because when you take up 700 and you increase it by 20, you get 720, and the 720 is exactly divisible. That is what they're asking you here. Find the smallest number which when increased by 20. So we take 700, we increase it by 20, and we get 720. And this 720 is divisible by 90 and 144. If two numbers p and q are expressed as p is a b cube, q a square b, a and b being prime numbers, find the LCM of p and q. So we just write down p is a b cube and q is a square b. For LCM, let me write the steps. For LCM, what do? We first write all factors, and then second step we take highest power. So all factors, one is a and b. Now we've got to take highest power. The highest power of a is 2 and the highest power of b is 3. So the LCM is a square b cube. LCM of p and q. The LCM of x and 18 is 36. So the numbers are x and the other number is 18. And the LCM is 36. LCM equal to 36. The HCF of x and 18 is 2. HCF equal to 2. Find the value of x. We know the formula, product of numbers equal to LCM into HCF. Now the product of numbers is x into 18, LCM 36, HCF 2. So x will be 36 into 2 over 18. So this becomes x equal to, cancel this will be 2. So x equal to 4. So the value of x equal to 4. Form a quadratic whose zeros are 2 and minus 1 by 3. So here the zeros, the two zeros, one is alpha is 2 and the beta minus 1 by 3. Then for the second step we find the sum of the zeros. Sum of zeros alpha plus beta, so that is 2 minus 1 by 3. LCM 6 minus 1 by 3, that is 5 by 3. For the next step we find product of zeros. That is alpha into beta. So 2 into minus 1 by 3, which is minus 2 by 3. Now we are ready to do the equation. Now we will write the quadratic equation. This is x square minus sum of roots plus product of roots. So we put the value x square minus sum we saw is 5 by 3, x plus beta, product minus 2 by 3. So x square 5x by 3 minus 2 by 3. If you want, you can take the LCM. So this would be 3x square minus 5x minus 2 over 3 is your quadratic. Form a quadratic in x whose zeros are root 5 and 2 root 5. So this is alpha and beta. So here we have the zeros, 1 alpha under root 5, beta 2 under root 5. The next step, we have to find sum of zeros. Sum of zeros is alpha plus beta, that is root 5 plus 2 root 5. Root 5 plus 2 root 5 is 3 root 5. Then we need to find product of zeros. Is alpha into beta, which is root 5 into 2 root 5. So 2 into 5, root 5 is 5, that is 10. Now it's time for us to write our quadratic. So a quadratic equal to x square minus sum of roots plus product. So x square minus sum, we saw our sum was this, so 3 under root 5, product was 10. So this is our quadratic. You can put this into K. Find the zeros and verify the relationship between the zeros and the coefficient. So first we'll find the zeros. We do this first. So it is x square minus 2 under root x. We'll take common out. X is common out. So x minus 2 under root 2. So x equal to 0, or x minus 2 under root 2 equal to 0. So here x will be equal to 2 under root 2. So the zeros are, one is alpha and one is beta. One is 0 and the beta is 2 under root 2. Next step, we got to identify the coefficient. So we have x square minus 2 root 2x. So if you see here, this is our a. A is equal to 1. The b is coefficient of x, which is minus 2 root 2. And there is no c, plus 0. So the c is equal to 0. To find the relationship, we have to find what is alpha plus beta. Alpha plus beta, 0 plus 2 root 2. So alpha plus beta is 2 root 2. Then we need to find minus b by a. Minus b by a, minus, and b is minus 2 root 2. A is 1. So minus b by a is 2 root 2. So we have seen that alpha plus beta is the same as minus b by a. So that's the first relationship. Alpha plus beta equal to minus b by a. Next we do alpha into beta. So we had alpha equal to 0, beta equal to 2 root 2. Then the a was 1, the b was minus root 2, and the c was 0. Now let us see what is alpha into beta. That is 0 into 2 root 2, which is equal to 0. And c by a. C is 0, a is 1, and that is also equal to 0. So we see alpha into beta equal to c by a. Product of roots equal to coefficient constant over the coefficient of x square. Find the value of a if x plus 2 is a factor of the polynomial. So we have say we have the polynomial p of x. It is ax square minus 2x. Now x plus 2 is factor. Therefore, when p of x is divided by x plus 2, the remainder will be 0. So let's find the remainder. To find the remainder, what we do is we do x plus 2 equal to 0, x equal to minus 2. So p of x is ax square minus 2x. Now p of minus 2, ax is minus 2 square, and here minus 2. Now by remainder theorem, we know that this is a remainder. This is 4a plus 4. But by factor theorem, we know that the remainder should be equal to 0 because it is a factor. So x plus 2 is factor. Therefore, remainder equal to 0. So 0 equal to 4a plus 4 minus 4 equal to 4a, and a equal to minus 1. This is your answer. Find the zeros of the polynomial. So you have 5 under root 5 x square, 30x plus 8 under root 5. Now the product should be 5 under root 5 into 8 under root 5. 5 into 8 is 40, 40 into 5. So I have to find the product should be 200 and the sum should be 30. So I can write 30 as 20 and 10. 20 into 10 is 100, 200, right? So 20 into 10, 200, and 20 plus 10, 30. So these are our factors. So we'll write 5 under root 5 x square. For 30, I'm going to write 20x plus 10x plus 8 root 5, splitting the middle term. So let's just write this again. 20x plus 10x, 8 under root 5. Now from here I've got to take common out, and what I'm going to take common out here is 5x. So what will remain here is under root 5x plus 4. Now from 10, from here common out, 2 under root 5 will be common out. So from 10, if I take 2 under root 5, what will remain? So to find out that, I divide it by 2 under root 5. So this is under root 5 into under root 5. So 2, this is 5, and this will cancel. So what remains is under root 5 here. Here also 8 under root 5, and I'll divide it by 2 under root 5. So you get 4. So what remains here is 4. If you're doubtful, multiply this again, and you should get back this 10x and 8 under root 5 if you multiply them. 2 under root 5 into 5, 2 under root 5 into 4. So now we have 5x plus 2 under root 5, and on this side under root 5x plus 4. To find the zeros, I'll do 5x plus 2 under root 5 equal to 0. So 5x minus 2 under root 5. So x is minus 2 under root 5 over 5. Here 5x plus 4 equal to 0. So under root 5 equal to minus 4. So x equal to minus 4 over under root 5. So these are your zeros, minus 2 under root 5 over 5 and minus 4 over under root 5. If you want, you can rationalize this by writing under root 5 into under root 5. If minus 2 and 3 are the zeros of the quadratic, find the value of a and b. So here they said the zeros are minus 2 and 3, which means alpha minus 2, beta equal to plus 3. Now the quadratic is given to us as x square, a plus 1x plus b. So a, coefficient of x square is 1, b is coefficient of x, which is a plus 1, and c is a constant, is b. Now we know the relationship between coefficients and the zeros. So alpha plus beta is minus b by a. So we'll put the values alpha minus 2 plus 3 minus b by a. Our b we saw is a plus 1. Here we have b over a, and a is 1. So 1 equal to minus a minus 1. So a equal to minus 1 minus 1. So a equal to minus 2. Now let's go ahead and find b. So for that we need product of roots. Alpha into beta is c by a. Alpha into beta is minus 2 into 3. C is b, and this is 1. So b equal to minus 6. So our answer, a minus 2 and b minus 6. Quadratic polynomial 2x square minus 3x plus 1 has zeros alpha and beta. Form a quadratic polynomial whose zeros are 3 alpha and 3 beta. Let's start with the first part of the sum. So we have the quadratic polynomial, which is 2x square minus 3x plus 1. A coefficient of x square is 2. This is b, and this is c. Now they said alpha and beta are the coefficient, that means are the zeros. So alpha plus beta we know is minus b by a. So alpha plus beta is minus of minus 3 by 2, because b is minus 3. So alpha plus beta is 3 by 2. This is 1. We know alpha beta is c by a. So alpha beta c is 1. So 1 by 2. So this is the second one. Alpha beta is 1 by 2. These values we are going to use them later. So next, now we are going to make a polynomial whose zeros are 3 alpha and 3 beta. So this is the second part. Now we are making a polynomial, making a quadratic. To make a quadratic, you need to know the zeros. So 1 0, 3 alpha, other 0, 3 beta. And the steps to make a polynomial, first step is we have to find the sum of roots. First step, it is 3 alpha plus 3 beta, because we have to make a polynomial with 3 alpha, 3 beta. So 3 common out, alpha plus beta. But alpha plus beta, we know the value here. Alpha plus beta was this value. So we are going to put here 3 by 2. So this is 3 into 3 by 2. So the sum of roots equal to 9 by 2. Now for the second step, we need product of roots. So we take the second step and we are going to find product of roots. So 3 alpha, 1 root, 3 beta. So that is 3 into 3, 9 alpha beta. 9 into alpha into beta is 1 by 2. So 1 by 2. That is 9 by 2. So now we have the sum and the product of roots. So we found the sum of roots. We can't write alpha plus beta because we've used alpha and beta already. The sum of roots is 9 by 2, and the product of roots is also 9 by 2. Now we are ready to make the quadratic. To make the quadratic, the formula is x square minus sum of roots x plus product of roots. So x square, sum of roots we saw was 9 by 2x, product of roots 9 by 2. So this is a quadratic. If you can take the LCM over 2, or you can take 1 by 2 common out here and what would remain here is 2x squared minus 9x plus 9. If alpha beta are the zeros of the quadratic such that alpha plus beta is 24, alpha minus beta is 8, find a quadratic with alpha beta as zeros. So we have alpha plus beta equal to 24 and alpha minus beta equal to 8. Equation 1, equation 2, we add them up together, this cancels. 2 alpha equal to 32. So alpha is 32 by 2. So alpha is 16. Now we need to find beta. So in equation 1, that is alpha plus beta equal to 24. We put alpha is equal to 16. So 16 plus beta equal to 24. Beta 24 minus 16. So we have beta equal to 8. Now to make the quadratic, again what are our steps? First step is to find sum of roots. So sum of roots is alpha plus beta here, which we know is 24. The second step is to find product of roots, alpha beta. 16 into 8, and that is 128. Now we will make a quadratic. To make a quadratic, it is x square minus sum of roots plus product of roots. So x square minus 24 sum of roots, product of roots 128. So this is x square minus 24x plus 128k. This is your quadratic.